Okay, so I need to go somewhere. New tab. New tab. Can you pull up your YouTube app real quick for me? Whichever, if you use a browser or something. I just want to make sure that it's actually working before I send it out, I guess. Or I can just send it out and you can tell me if it's working or not. Okay, so Canvas. Okay, and compose, select course. So we are 20,000 to all link for today's class. And okay, somebody got that email? Is it, do you see this screen-ish? Oh yeah, I did.
Like on my Ken?
Oh, on the Ken one, yeah. Because that's the one that I have access to. Shivlay, do you have your email? No, not on your phone? Let's get that going, by the way. Down the road, when you have a job and stuff, emails are like everything, you know, just, again, I'm, what? Sorry, the thing echoes if I play it here. Don't worry, I paused it. It's okay. Okay, last thing I need is share screen. And YouTube.
In this video, you'll
Oh, it says Zoom. I want. You never got that email? And did I send it to the wrong group of people? Let's see. Okay, cool. So I'm guessing everyone else must be getting it roughly the same time. And yeah, and okay, can you bump up your volume and tell me if you can hear me clearly? Okay. Now turn it down because it'll just keep on echoing otherwise. Okay, thank you. So we just needed to do that quick test. Man, there must be a simpler way than that. Yeah, but then why can't I click on it? Okay, 2 people are watching, so I'm guessing we have some audience people. I'll put up the slides, obviously, but I'm going to move the camera just a bit this way. So you can partially see the slides, but I also want to have this portion for you so that, if I write something down, okay? Okay, cool. Okay, folks, thank you all for your patience while we configured that stuff out. And like I said, the video is available to you guys as well later on. For everyone who's here and the people who are watching at home, please just remember that we definitely want to be here in person. So if it's possible, try to make it in class. And that way, first we have a few amount of students, so you have better opportunity to have group discussions and stuff if you're here in person, okay? Plus, we also avoid this sort of lengthy transition and stuff. Anyway, last time we were talking about budget constraints, and we sort of like on Monday's class, I gave you an overview of why and how this is constructed. So for instance, if I were to ask you why we have a less than and equal to sign there, your answer would be? Right, because if you have a certain amount of budget, if you allocated $40 to weekly spending on, pizzas and hamburgers, then we are assuming that you're not going to add more to that pot. You're either going to spend the exact amount or you're going to just spend less. And realistically, we're just saying, at least the way we're going to doing our calculations, we're going to assert that we're going to spend the exact amount. Okay, so the three requirements of a budget line were the amount to be expended, the price of good one, and then the price of good two. Okay? Now remember, the reason why we have this, the reason why you only need those three things, okay, is that these values, the quantity of hamburgers and the amount of tacos you're eating, so tacos and hamburgers, they will vary, right? I mean, if you have $40 allocated to you, it sort of depends what combination of the two that you want to eat. Some people want to eat one hamburger and more tacos. Some people want two hamburgers and less tacos, so on and so forth. So the only thing really are fixed are these three items, okay? So the other two, of course, are the stuff that we choose, and these are, of course, then the other parameters, okay? Without throwing fancy stuff at you, we also discussed how to find the slope of the budget line, and I drew a very, let me say, a normal y equals mx plus b graph, and showed you why the slope of the line is the price of hamburgers or the price of tacos, okay? So one quick way to essentially remember then is that if you have tacos on this axis and hamburgers on this axis, and if I have some budget constraint which goes like this, okay, so this is your budget constraint, then the slope of this line, so slope of line is just going to be negative price of hamburgers over price of tacos, okay? And what does a negative tell us? What's the intuition behind the negative? Everybody knows.
Increase.
It's decreasing, downward sloping, okay? If we have a line like this, like a line we'll see for supply curves and stuff later, then it just takes off into infinity. That's increasing. So then you would have a positive sign here, okay? So that sort of was the intuition, and hopefully you now understand how to find the slope of a line. Okay, I want to do a quick practice problem just to get people back up to speed, because this is sort of the last thing we discussed on the slope stuff before we took off, and I just want to jog people's memory. So we're just going to do a quick practice problem. Also, for the people who are watching at home, if you're currently watching live, drop your questions in the chat. And I know that the chat requires you to sign into your YouTube account, but just sign in because that way you can just type in a question and I can address it, and so on and so forth. Okay, so suppose you have some sample line which looks like this. Okay, now in this construction as well, I am asserting that x is on the vertical, the horizontal axis, and then y is the vertical axis, as is usually the case. I want you to find the slope of this line. So find slope of this line. Let's take 2 minutes to do that. And remember, all you're trying to do is you're trying to convert this into the y equals mx plus b form. I also want to assure you, as I did at the end of last class, that you will not be required to derive this in the exam. Even in this form or that form, you can just simply plug into the formula. But if you understand how to find the slope, then you will understand the intuition much better, especially when you try to locate equilibrium demand, stuff like that. So let's try and find the slope of this line. Should we have questions? No? Okay. All I'm going to do is I'm going to convert this construction into the y equals mx plus b construction. Mx plus b. Answer, if you have one. Or if a question is there, that's fine too.
Is it y equal to x plus 7?
So, whether this is wrong or incorrect, I just want to quickly emphasize that, remember, if you're going to go for the y equals mx plus b, the way you want to think about it is that there needs to be nothing in front of the y, and there needs to be something in front of the x. Now, if there's nothing in front of the x, that means it is, what is it? 1. 1 times something is just that something, okay? So if m is 1, then it's just going to be y equals x plus b. But like over here, how do we go from this form to this form? Sierra has a better try.
Wouldn't you like subtract this 7, that'd be the y, so be -7?
So the way you want to think about it is all I'm trying to do is I'm just trying to convert this into this form, okay? So if you have 2x plus 3y equals 7, and you'll notice that y is already on the left-hand side of the equal to sign, right? So I'm just going to go ahead and subtract 2x from both sides. What does that do? It cancels. And then what are we left with? We're left with 2y equals 7 minus 2x. Okay, so you had the sort of the right idea. Just remember about the sign. Okay, all you're just doing is simple just changes and manipulation of that original equation. Now, what's in front of the y? 3. So 3 is multiplied by y. How do I get rid of the 3? You just divide through both sides. So then 3 will cancel, and you'll be left with y equals 7 minus 2x over 3. How else can I write this whole construction here? How else can I write this? This can be written as y equals 7 over 3 minus 2x over 3. Okay, now, do you see the parallel between this and this now? So, what is b?
7.
7 over 3. Okay, that's the only constant. That's just the number, but that's the intercept, which is just b right here. What is the slope of this line? So
That is 2.
negative 2 over
Over 2.
over 3. So the way you're thinking about it is the negative 2 over 3 is just multiplied by the x. So this whole thing, is just your m. What you would also realize is that this equation that I just made for you is a sample budget constraint, okay? The 2 is the price of x. The 3 is the price of y. And then you have $7 total that you can spend. So now it's up to you to decide how you want to spend it. You can have one of each, probably slightly more of x, slightly less of x, so on and so forth. And then pay the prices, 2 and 3, and then you can spend all the $7 that you have. You'll also notice that because you have a negative slope, your budget constraint is going to look something like this. Question. Somebody's email, I hope it's not one of the students. Quiz, hey, do you have a link? I'm having trouble finding it. I just sent the link. I just sent the link. Let me know if you don't see it. Questions here.
So like, after we find out, would you make us like graph it then?
So the graphing part is also something we're going to just talk about, but I'm not going to make you graph it in the exam. I'm going to give you the graph, and then you're going to tell me stuff about the graph. So you still need to understand how the graph basically works, okay? Me making you want to make you the graph just simply just is a waste of your time, right? I mean, an exam is about your intellectual understanding about all this stuff. If you making the graph is just a waste of time, I'll make the graph for you, and you tell me stuff about the graph, okay? And we'll talk about all that stuff in just a sec here. So, is this okay? How to find the slope of a line? Obviously, I walked you through it, and I feel like people are on the cusp. They just generally get the idea. But what I want to do is just do one more practice problem. Just one more. And then we'll be good to go. Let's find the slope of this line. Exact same idea, just remember, you have to convert to this form. Whatever is in front of x is slope, and then the remaining number is just the intercept. You did get that email, right? At the top of the class? Okay, perfect. So she should have received that right here. Okay, go.
Y equal,
So just tell me the slope directly, and then we'll do the, what is the slope of the line?
is it X over 6, negative X,
So the x is independent. Whatever is in front of the x is basically, and I think you're close. What is it that you have?
so I have Y equal 20 over 6,
20 over 6,
and then minus X over 6.
x over 6. Almost there. Ciara, what do you have?
I have y equals 20 minus x over -6.
Wait, did you say that y equals,
20 minus, I had 1x just to put a number,
yeah,
and then over -6. But wouldn't that be a positive thing? I don't know.
so you are, this is more correct. I think Shirley just missed out on the sign there, okay? Let's just go ahead and walk through step by step so that we're all, on the same page. So again, the goal is whatever is, so you just want the y on the left-hand side, everything else goes on the other side. So first I'm just gonna do -6, and what are you trying to do? You're trying to get rid of this x.
Yes, but if you try to get rid of it,
So-
actually you have to add positive 6.
So we'll worry about that in just a second, but like on this side, if you just have to get rid of the x, what would I do? Just like we did in the previous case.
What would you do? You just minus X.
Yeah, just -x. That's it. Perfect. So this cancels. I think we both agree on that. And now you're left with like the -6 equals 20 minus x. Perfect. Now what's in front of the y?
You got a 6.
So you just do -6. You just divide through a -6. So this cancels. You have y equals -20 over 6, because there's a negative here, so just multiply by -1. And then there's a negative here and a negative here. What is a negative times negative?
Positive.
Positive, okay? So then you're just gonna be left with plus x over 6. So the slope of the line then is,
-20 over 6.
the slope of the line.
It's X over 6.
So again, the x is just the line itself.
Okay.
So whatever is multiplied is just 1 over 6.
So the one with the x is the slope.
Exactly. M times x.
Okay, I was thinking it was the first one always.
Okay. So whatever is multiplied by the x is the slope. And then, of course, the more is back as I'm trying to make a point. And then just the number is the intercept. Okay? Question.
So how do we get negative 20?
So notice how you have this. Now all I'm trying to do is I'm trying to separate these two out, right? Because we want the final answer in this form, and this is just mathematical. The term at least we would use in Asia is de-elsification. But de-elsification is a term that's not used in math in North America, so I'm not going to bother you with that stuff. Just think about splitting this total fraction, okay? So let me give you like a more simple example. So let's say you have 4 minus 2 over 2, okay? What is the, without even doing anything, what is the answer here? What does this simplify to? 4 minus 2 over 2? Just 1, right? 4 minus 2 is just 2. 2 over 2 is 1. So this is 1. Now what I'm trying to do is I'm trying to separate this to get the same answer. So here's what we're going to do. We're just going to write this as 4 over 2 minus 2 over 2. And then, of course, this is just 2. This is just 1. So your answer is 1. Okay? Now, let's flip this. There's a negative 2 here. What is the answer now?
-1.
-1, okay? And what are we doing? All we're doing is just splitting the exact same thing. So 4 over -2 minus 2 over -2. So there's a -1 here, so you can just translate that like this. Same thing. And then there's a negative here and a negative here. So then this becomes a positive. So then you're just left with -2 plus 1, which of course is -1, as we just determined. And that's exactly what we're doing here. Okay? There's a -6 here. So I separate it, I bring the 6 up here. And then there's a plus and a plus, so this becomes plus, and it's x over 6. Whatever is multiplying the x, 1 over 6 is multiplying the x, which of course then is your slope. Question. And this, of course, is your intercept. Make sense? Good. I like that. We're asking questions. We're trying to figure this out on an intuitive level, and it'll really help you. Okay. Now, obviously, in this construction, this stuff should make sense in your head as well. Okay. So let me just erase this. Notice that we are trying to figure out the slope and what this line essentially looks like. Okay. So we have something like this. This here is -y. This here is -x. Okay. And if you were to just try and plot this line, what would this line look like over here? You can again just use stuff you already have. Okay. Now there's several ways to do this. You can start thinking about it in the simplest possible ways. Okay. So one thing you always have to remember is that in the center here, that's 0, 0. Okay. So that's just like the center. And then x increases in the positive direction towards the right, towards infinity, and then in a negative direction towards infinity on the left. And the same idea applies to y up and down. Okay, so the two-dimensional plane, basically. Okay, and all of this, you would think, wait, we're so far detached from all the food stuff we were talking about. Actually, it is related, and I'll show you how. So we're trying to plot this line. Okay, now x minus 6y equals 20. Okay, how would I plot this on this chart? You already have some really interesting information. Okay, you just figured out that the intercept is -20 over 6. Where does that go on this line? Like on this plane?
Wouldn't it like not even be 1?
-20 over 6 is a negative number. Okay, so notice how your y goes up in this direction. Okay, and then you have a line which goes up like this. So your slope, the intercept, -20 over 6, is then this distance right here. Oh, sorry, I just need. You know, since I'm squeezed to say, I'm just going to erase this just to get like a better illustration. That way, it's just super clear. Negative x, x, y. Goes. Okay. And then we were using this equation, and we had determined that the slope was 1 over 6, and then the intercept, b, or the intercept, was -20 over 6. Okay? So remember, the construction that you just have created is this, 1 over 6 x minus 20 over 6. Okay, now, when I put something here, Sierra was like, okay, I don't get it. So let's try and break that process down even further. I need to start making some complaints. You can't roll when I'm trying to teach. No, they're not, they're using a blow dryer. Not a blow dryer, a blower. Sorry, a blow dryer. Okay, so try to relate what's written here and here and just try to visualize it. So here's how we do it. Remember that on this specific axis, right here, what is 0 on this line? So on this line, what is 0? Notice how there's some value of x here, right? X is increasing this direction and decreasing this direction. But at this, on the line itself, what is 0? So the point of origin is right here, dead center. But like over here, what is 0? So we know x has some value. Let's say x is 3. But what is 0 here besides that? So again, x is positive. That is y, right? So here's how you visualize this. X is going positive in this direction, negative in this direction, but then y is like this. But when you just go right here at this point, y is 0 all on this line. Okay?
Yeah.
Right, sure. And again, if you, how's it going? And everything okay with the hot water situation?
Yeah,
Okay, cool.
Okay.
Cool.
I need the gas companies to come out and change the meter.
Okay, cool. Now, everything on this line besides x, so y, of course, is 0. Okay? So here's how you start trying to like visualize stuff like this. Let's assume that we're just talking about whatever's happening on this line. If your y is 0, I'm plugging in the value of y as 0. Can somebody tell me what x is when you solve that equation? If y is 0, can somebody tell me what x is? This is just like your basic manipulation. So I'm just saying, everyone is fine. Y is 0. How do we solve for x? So you have something like this. All you're trying to do is you're going to solve for this, whatever this value is, x. Okay? And so all you have to do is, since you just need to separate for x, so first I'm going to add 20 over 6 on both sides. Okay. 1 over 6 x. And then there's 20 over 6 plus 20 over 6. Sorry about that. And then this term will just cancel. Okay. Click on that to not confuse people. Wait, what was that?
Yeah.
Sure. There, sorry. That cancels, and you're just left with this side. Notice how you can cancel the 6's. So x is just going to be 20. When y is 0, anywhere on this line, according to this equation, your x is 20. Let's say x then is 20 right here. Remember, it only has to be on this line because we are asserting that y is 0.
Is y always represented?
No, so that's sort of the point. We're trying to construct this line, okay?
Okay.
Now,
So
once,
it's like through 0 in there.
right, so the point is that this line, it just sort of goes through this point right here. We just discovered that. All we have to do now to complete a line, if you go from like this spot to this spot, what do you need to complete a line? You need 2 points, right? You just found out one of them. Now you need the other one. So if you already put y equals 0, the next thing you need to do is just put x equals 0 and solve for y. Okay? So if you're okay with this, I'm going to write stuff on this side now. So we just had this original line, minus 20 over 6. All I'm going to do now is plug x as 0. Put this as 0. So you're going to have y equals 1 over 6 times 0 minus 20 over 6. And what is this value? If there's a 0 here. What is 1 times 6 times 0? 0, right? Whatever's multiplied by this thing is a 0. And then you're just left with this. Y equals negative 20 over 6. You will then, of course, realize that this direction y is positive, this direction y is negative, so negative 20 over 6 is somewhere here. The more direct way to do this is what I was telling you at the top, that that's just the intercept. So if it's y, it's going to be this point, and you have this point now, and you have this point, so your line basically looks something like this. So this is just an example of a line. A budget constraint doesn't look like that, but this is what the line essentially looks like. Now, I know usually the way people understand this is that it's an incremental process. People process it in one time, they practice a bit more, and then they sort of grasp it. You have to realize that I am not going to give you an exam where I'm asking you to calculate the slope of a line, none of that stuff. But here you have a budget line, and here we have some manipulations of how those lines are moving. To fully grasp this, having an understanding about this is very, very crucial. Okay? I would again also urge you to please read the book. And just for practice, try looking at some tutorials from back in the day when, this stuff was just sort of being explained, and try to intuitively relate this equation stuff to the graphs. But we're not quite done yet. I like to walk people through this multiple times, and then when I sense that, okay, now you're getting the general idea, then we're going to move on. Okay, so we're going to practice a bit more, this time all the way from the top. I'm going to give you an equation, then you're going to find the slope and the intercept, and then we're going to try and apply it. And what I'm going to do is the example we're going to use is going to look exactly like what a budget constraint looks like. Okay, the amount of money you have to spend, and then the prices are given to you, and then you're sort of deciding what is that limit beyond which I cannot go, beyond which I cannot spend. Okay, so okay, which one did I want? Okay, maybe this one. So let's do two x plus 5y equals 20. Find slope of line. Find intercept. Let's get to that, and then once we are sure about that answer, then we'll try and apply. Okay. So the idea again is we're trying to convert all of this into y equals mx plus b form. Brian, are you familiar with the y equals mx plus b form? Okay, cool, that's really good. Gardner, your high performance building partner. Okay, we have some answers. Sarah has one.
I got y equals 20/5 minus 2x/5.
Okay, so that seems correct to me in terms of the equation form. What is the slope of the line then? Just that end. What is that?
Negative 2x/5.
So again, I'm just asking for the m. Whatever is multiplying the x. Almost there.
-2/5.
So that is the correct answer. So in the sense that whatever is in front is basically the slope, and then all that, just that other number is basically going to be the intercept, okay? Let's just go ahead and quickly walk through that. So you have 2x plus 5y equals 20. I'm gonna subtract 2x from both sides. You're gonna be left with 5y equals 20 minus 2x. Again, you have to get rid of the 5 in front of the y. Divide through both sides. 5 cancels. Y equals 20/5 minus 2x by 5. So this seems to be what you have. Remember, this is what is multiplying the x. That is the m, or slope. And then 20/5, which is what? 20/5 is? This is 4. Right? Yeah. So you are right. That's the intercept, and then that's 4. So now you have basically the starting blocks. Okay. Going back to our trusted plane, how then would we plot it? Same idea. In this equation, you can start by plugging in first x is 0, find the value of y, then put y is 0, find the value of x. For an equation like this, it is like literally direct. If y is 0, what happens to this term? This goes 2x equals 20. Therefore, x equals 10. Okay? When y is 0, x is 10. Now do the opposite. 2x plus 5y equals 20. When x is 0, so x is 0, what happens to this term? Find those. This is 0, 2 times 0, cancels. So left with 5y equals 20, therefore y equals 4. Okay. This axis, x is 0. So y is 4. You join the line. That's your budget constraint right there. This triangle represents everywhere where you can just operate. You can buy any quantity combination of x and y within this triangle. And anything out of it, you can't afford it. You don't have the resource. This line, and let me just color it using a different color. Represents your budget constraint. Anything in here is good. Anything on the line is good. You can afford anything on the line. You cannot afford anything over here. Does this make sense about figuring out the budget constraint? Okay, so now the slope stuff, I'm hoping and I think people get it. We're just going to do a quick practice problem of just drawing the budget constraint. Remember, in the exam, I'm not going to ask you to draw the budget constraint. I will give you the budget constraint, and then you're going to tell me stuff about it, okay? So just knowing how to make it actually helps. plot this line. So just plot it. Same idea. First x is 0, find y. Then y is 0, find x. Get 2 points, join the 2 points. That's a budget constraint. And emails. Question. Okay, so what are the points?
9 and 9.
That's correct. Okay, so this is 0, 9. Always remember the notation, x is first, then y. Keep going. Budget constraint. So one last thing, before we actually just look at what's on the slides, and that is, if you notice the weekly budget for fast food, okay? Suppose I had a line which looked like this. Q hamburgers with Q tacos equals some budget, whatever this number is, 50, 100, 200, who knows. What is the price of a hamburger and the price of the tacos in this instruction?
Q.
So you have something multiplied by Q, price, plus price multiplied by tacos, and I'm saying that this is what it looks like. Almost there. What is the price of hamburger? What, when you multiply with itself, this gives you the same thing. 1. Okay. This is nothing but 1 times Q ham plus 1 times QT equals B. And of course, then this 1 is this is price, and then this 1 is this price. It makes for a really good warm-up question in the exam, so just be aware of this simple question. Questions? Make sense? Okay, so we talked about this idea of, you trying to buy whatever combination, it's something we talked about last time. Different combinations of what you eat for a certain amount of prices, and your expenditure is going to be the same. And that's who we are as people. One person prefers this, a different person prefers this, so on and so forth. Okay, so you just figured out how to construct a budget line. Okay, if you have this many, the extent of your budget line looks something like this, so you cannot be outside this triangle because you don't have the resources to buy that stuff. It's possible you have 5 tacos a week and 2 hamburgers. You can be anywhere else on this blue line, wherever. You can be inside if you like, but not over. Okay? The question then becomes, what happens when things change? So now I want you to visualize this stuff, not just by the geometry of it that we were doing, but just intuitively. Let's say the price of tacos goes up. Nothing else has changed. You still have the same amount of money you allocated at the top of the week to spend on tacos and hamburgers. If price of one of the goods goes up, what do you think happens to the total triangle that you have? Like intuitively, what do you think will happen if price of one of the products goes up? Brian knows.
Your spending will go up.
So remember, your spending cannot go up. Your spending is fixed. remember how we were talking about the budget right here? The budget is fixed. If price of something goes up, what can only happen?
A bit less of it.
You will just get less of it. So the way you want to think about it is we are assuming that the budget is going to be fixed. Okay, and that's more of a realistic scenario. Think about it. If you have a fixed job where you're earning a certain amount of dollars a week, and if stuff gets expensive and your income is not increasing with it, then you're going to consume less of stuff. That's just how it's going to be. So the point I'm trying to make here is that if there's a change in taco price, the change could be, it could decrease, prices is cheaper, or it could increase. Based on that, the triangle area that we have been looking at, is right here, is going to change. And we can exactly point out how much the change is going to be based on how much price changes. Okay, so let's try and understand this using the graph I actually already have up there. So I already have one thing drawn in red. I'm going to use a different color to make my point. This equation gave us that line. Notice how one is multiplying x, one is multiplying y. Now, price of x plus price of y equals 9. We know that if we're using this, then both of these are 1. We know that. 1, 1. Now I'm saying that the price of x actually increases to 2. If this was 1, now it is 2. Everything is the same with y. How will I write the new equation? So the p is the 2. So it's 2 times x. X is the stuff that you actually buy. Plus, everything else is the same. So the price of y does not change. It's still the same. Equals 9.
So that would just affect the x.
So at least in this example, we noticed that the price of x went up, but the y was same. And so you're right, this is the way the construction will work, is that one corner here is not going to change at all, but then the other will. So we're going to do the same thing again. Y, we put in as 0, and then what is your x going to be now? If y is 0, what is your x? 9 over 2, which is 4.5, so that is correct. And that's all you do. You notice that if you put x is 0, y again will be 9, right? X is 0, y is 9 again. So what will change, I'm using a different color. That 4.5 and 0. Because one price went up, the total triangle that you had to work with now is smaller. Which triangle is smaller? On the left, right? This one is smaller. And that's sort of what we're trying to make it. If your income doesn't increase, then these are the kind of outcomes you'll face. Your ability to buy stuff is going to be restricted. Now, one thing people automatically confuse with is they automatically think that, okay, if price of X went up, that means by definition, I'm going to buy less of X. That's not necessarily true. You like X. You might reduce the consumption of X, but it is possible that you also proportionally reduce your consumption of Y, because you still want to preserve some of your ability to buy X, okay? X is part of your utility box. So this is what it's going to look like, okay? And this is just a very teeny sort of idea. Price changed. I could have done the exact same thing. In fact, let's do it. That this was Y. Let's do this. And this is Y, so I'm gonna do that as 1. 1 and 1. And now I say that the price of Y decreased. The price of Y was 1. Now I'm saying it decreased to 0.5, 50 cents. How will I write this equation into the new equation? What would that look like? X is still the same. So X is just X, and then it's going to be plus. The price of Y is half of it now. What we have?
0.5.
0.5, that is correct. So 50 cents only. 0.5 times Y equals 9. Now you can do the exact same thing to figure out that new line. And you put X is 0, what value of Y do you get?
3.
You're gonna have, it's just, you just do this. 0.5. This actually turns out to be 18. Do you see how you go from 9 over 0.5, right? It's okay. Also, just a quick pro tip, please do carry calculators. I don't want you, there's no math here in terms of calculation. Don't spend brain power trying to worry about what is 9 times 3. Just use your calculator for that, okay? 18, so if X is 0, Y is 18. Remember, X is 0 on this line, so you're gonna have 0, 18, okay? And then everything is pretty much the same. So if I have a different color, let's use black this time. Original line, new point, much bigger triangle. Triangle is much bigger because now your space has increased. Y is just cheaper now. You have the same amount of money as before. One bit is cheaper, so you're great, okay? And you can do any kind of mix and match you'd like. It's possible that both price of X and Y change. X goes up, Y goes down. Both go up, both go down. Anything can happen. All you have to do is you have to recalculate what the budget line is going to be. And then you can visualize yourself whether your budget set increased, decreased. Sometimes it's hard to say. Sometimes you're going to have a pivot of the line, and then you'll be like, okay, where do I have more budget here? What's going on? So. Questions, thoughts? Question? Okay. Doubling, halving, factor could increase, decrease, number could increase, decrease. The one scenario that is interesting is change in income or both prices. So the both prices one is the same, right? I mean, I just mentioned both prices could increase, both prices could decrease. The one thing that we haven't talked about is what happens if, let's say, Sierra is the person we're talking about, and everything remains the same. So the prices are the same. But now she gets a pay raise. She was a manager, now she's a senior manager. And she's got a 10% pay increase. How will we show changes then? So what is changing here if your income is increasing? That is correct. And so what will I change here? It's the 9 stuff. That's your budget. So let's assume she has twice the money, or slightly more than twice the money. X plus Y equals 20. Everything else is the same. Price of X is 1, price of Y is 1, but she has more money. What do you think is going to happen to this triangle? It's just going to get bigger. The way it'll actually get bigger is going to be a proportional or parallel shift. It's going to be 20 here, and then 20 here. Sorry, I'm running out of space literally. But you're going to see a parallel shift in those lines. So This is the red line. It's hard to show parallel because scaling is off, but that's the idea. Okay? So anytime you are sort of worried about what it is going to look like, just make the line. Put x equals 0, find y. Put y equals 0, find x. Join the two lines. Now you have a line to work with. Okay? So that would just literally be like a starting point. Okay? The slope stuff that we were talking about is also important because finding the slope of the line actually helps you determine consumer demand and equilibrium points and stuff like that. Okay, everything is super zoomed in. I will zoom out. Okay, let's talk about Angel's Law, something we talked, and this is sort of more like an FYI thing. I was hoping to start maybe the next chapter today, but I don't know if we'll be able to do that. Instead, what I'll do is that once I wrap up this chapter, I want to spend like a couple of minutes trying to talk about the homework, which is going to be due on Monday's class. Today's Wednesday, so on Monday's class. Angel's Law, of course, is the more wealthy a consumer becomes, the percentage of income spent on food decreases. So here, of course, you can see here in the United States, by the time we got to about 2002, 2004, the percentage of income has sort of stabilized. Notice how this is not decreasing further, but stabilizing, and this is sort of like a point of concern amongst economists. So it shows that average incomes in the United States have sort of stalled, and that's bad for society in the long run. Share of total food, so percentage, you have disposable personal income. You notice again, the more disposable personal income you have, these are billions of dollars, so this would be actually $12 trillion. So you notice how, as this increases, the total food percentage decreases. Okay, indifference curves express preferences, budget lines express affordability. Okay, the indifference curves, stuff we were talking about, that was wherever you are on that indifference curve, you're going to have a certain choice. You are equally as happy, but you can mix and match. Whatever you want to do that, it just sort of depends on you, and then whatever your budget constraint is, okay? Chapter 4, which is the next one, unites the concept of indifference curve with the budget constraint to determine consumer equilibrium. The idea that your happiness level is asking you to get a certain combination of hamburgers and pizzas or hamburgers and tacos, and then what you're restricted by is the amount of money you have to actually buy that stuff. Okay, so happiness with whatever you're trying to consume is not free, and which is why you have all kinds of political issues where some people are like taxes should be higher, taxes should be less, give more people, stuff like that. Okay, but just on a more elementary level, that's the idea. To satisfy your happiness with whatever you're consuming, you need to have a certain amount of money, and we're going to try and see, based on the exact amount of money you have, and based on what the prices and stuff like that are, how much can you actually consume, okay? Don't go away just yet, because I do want to go over the homework real quick. Let's pull that up here. Courses, BMRT. Okay, so I need to do student view. Let's go back here. Student view. Not now. Close this. Again. Oh, I had the wrong course. That's what I was thinking. What? Okay. Leave student view. Courses. Okay. Student view. Okay, so when you click on this, you will actually have a Word document, and what you have to do is you have to complete your answer, and then you have to upload the file on Canvas. I would prefer if you do that. If you run into some technical issue, you can hand in the homework to me or just send me an email with your doc file, basically, okay? Anyway, so here we have complete the following table. You've already done stuff like this. And then we sort of get into some of the stuff we have been talking about, this class and Monday's class, trying to look at some of these issues of using the following graph, let the number of Coca-Colas on the vertical axis and the number of wings be on the horizontal axis, and then I'm asking you questions, stuff like that. And then here we have what we have been discussing today. Suppose this is the total budget. Draw the budget line. I again want to assure people I'm not going to ask you to draw the budget line in the exam, okay? But I want you to practice so that you're ready for the exam, okay? And then we do all kinds of manipulations. Price of something goes up, price of something goes down. If you struggle with something, watch this. Available on YouTube. I'll send the link and then read the book. The book is really simple and completely explains what's going on here, okay? And again, I hope people have a general sense of what we were doing today, right? Okay, just the idea of how to construct those graphs and stuff like that. Even if you sort of struggle with something, turn in the homework, okay? We're gonna go through the homework in detail next time. So I wanna make sure that people are at least attempting the homework, and most of your grade is for the attempt itself, okay? So I was here. Are there questions about anything? No? Okay, perfect. So I will see you guys on Monday, okay? So if there's anyone watching here, I don't know. Okay, somebody was watching. Okay, whoever's watching, so I'm gonna go ahead and close the stream and see you guys later. Close this, end stream.